We're currently looking at the Unit 30 review. This is covering our chapters 11, 12, and 13. I'm going to be going through all of the answers for the review. Please make note if you have any issues so that we can talk about them in class. Now, on number 1, this is actually a problem that we have seen before on a quiz. We're talking about a Gallup Youth Survey where we're randomly sampling 1,028 U.S. teens, and we find out from that 8% of the teens rank Napoleon Dynamite as their favorite movie. Now, obviously the population of interest here is the US teens, so we know for a fact that that first one here is correct. Then it goes on and says 8% is a statistic and not an actual percentage. That is also true. So this one's true and this one's true. The sampling design should provide a reasonably accurate estimation of the actual percentage of all US teens. Believe it or not, we had some issues with this in class, but that is true. And the reason why this one is true is because that number, 1,028, is such a large number. Okay, remember, it's not about what proportion you are of the population, but that the actual answer itself, that the number itself that we're dealing with here is significantly large enough. So the answer to number 1 is E. Okay. Now, on number 2. Number 2 is talking about a district randomly deciding to test high school for ADD. 3 high schools in the district, each grades 9 through 12. Board pools all of the students together and randomly samples 250 students. Now, with this one, this is a simple random sample. Even though they talk about different breakdowns we could have, each student here is equally likely to be chosen because it is randomly sampled. Okay, so that is why the answer on number 2 is B. On number 3, placebos are a tool for blinding. We are only talking about blinding here. So that is why number 3 is C. Sampling would be if I talked about stratified or cluster, something like that. Blocking is where I'm grouping people according to commonalities. Control, placebos can be used as a control group, but the idea is to blind its group against which type of a treatment it's getting, and randomization has nothing to do with this. On number 4, diagnosed with thyroid problems that have been diagnosed in the past, a researcher identifies the puppies and then keeps records for several years to see if developed thyroid problems. This is when you identify your sample and then watch to see what happens. This is a prospective study. Okay, so that answer is C. If you identify and then observe, that is prospective. Rather than looking back at past data, that is retrospective. On number 5, another problem that you have seen before. Whenever we have a sample that we're trying to simulate using either numbers or other types of events, we have to make sure that we take into account whether or not something represents the correct proportion of the total population, and if we have to worry about repeaters. If we're talking about 2 eggs being pulled from a dozen, you're going to pull out 1 egg, check to see if it is a good egg or a bad egg, and you are not going to use it again. Because of that, if I look at this, letting 0, 1, and 2 represent rotten eggs, and 3 to 11 the good eggs, that right there is 1/4, or 3, that are in fact rotten. Generate 2 numbers, okay? Ignoring repeats, that's the key thing here. Ignoring repeats means 1's okay. Randomly generate 0, 1, or 2, that does not distinguish between whether or not you're drawing repeats, and it also does not relay to the proportion of the population that is rotten. So number 2 is not an object, not one of our answers. Since 25% of the eggs are rotten, let 0 equal rotten, 1, 2, and 3 be good. That's okay, but the problem here is this doesn't talk about repeats. So that is why number 3 is not a choice. The only correct answer here is in fact A. On number 6, we are talking about designing an experiment comparing 3 different types of pain relievers suffering to volunteers suffering from arthritis. Now, we're looking at this one. This experiment randomly assigns medication broken down into 2 groups. we have one factor. That factor is the medication. We have different levels, but we have one factor, and that factor is the medication, and it is blocked by age. So the correct answer here is D. Blocked by age. Blocking reduce is variation between your sample groups. You look at something that you might have in common. We were talking about this in class. Under 60 and over 60, they might have significant different sources of pain. Heck, if you're over 60, you might be falling apart a little bit more than somebody under 60. Under 60 might be suffering from pain due to injury or illness. Over 60 tends to be strictly arthritis. On number 7, we're again looking at one of these select which apply. So it's asking you which is true. Now in this problem, he wants to increase car sales. So he's going to keep a list of names and addresses and send those all out to everybody. At the end of the month, sends out surveys asking them why. 1/3 return the survey, 44% indicating they found a lower price elsewhere. Now the population of interest here is all potential buyers. That's what he wants to figure out. All of his potential buyers. This survey does suffer from response bias. Non-response bias, because what about all those people who did not respond? Maybe the reason why they did not respond is they did not feel comfortable with the salespeople. We don't know. Now this one says because it comes from a sample, 44% is a parameter, not a statistic. That's backwards. 44% is a statistic because it comes from the sample. Parameters come from an entire population or from a census, which means 1 and 2 are true. So that means the answer to number 7 is in fact C. On number 8, what's true about sampling? An attempt to take a census will always result in less bias than sampling. That's not true. It doesn't matter what your attempt is, it's what do you end up with. A sample is a sample is a sample. You could attempt to take a census and be extremely off for it. So it may not have less bias than traditional sampling. Sampling error is usually reduced when the sample size is larger. That is your goal when you have a sample. You want to have it as big as possible to reduce as much sampling error as you can. Sampling error is a result of random variations and is always present. That is true. Sampling error is different from bias. Sampling error is always present because your samples, depending upon what you have, your answers will change from one sample to the next. Bias is different. Bias is bad. Sampling error is okay. So just always remember, bias is bad. Error, it's okay. It's not something that you want, but it's definitely not as bad as bias. You cannot avoid error. You can avoid bias. I'm sorry, the answer is not A. On number 8, the answer is B. On number 9, what statement about bias is true? Well, the true statement here is only part 2. Bias results from a sampling method likely to produce samples that do not represent the population. If your samples, for some reason or another, are not reflective of the population, it's typically because of bias. Random variation does not create bias. That creates sampling error. That's different. Bias can be reduced when bias is not reduced when the sample size is large. Sampling error is reduced when the sample size is large. Bias can be created in all sorts of different forms. If you have a bad question, that's going to produce bias, and just increasing the sample size does not reduce that form of bias. So in this problem, it is only 2. The answer is B. Again, bias comes from something that does not represent the population. Error comes from random variation. Error comes when you have a small sample size. Error can be avoided. Error can be minimized. Bias needs to be avoided. Number 10, oh, buddy, you better get this one right. Important in designing a good experiment: randomize, control, replicate. All 3. That is one of the most important things that you remember. Randomize, control, replicate. Control what you can, block what you can't, randomize everything else, and then always try to replicate your results just to make sure that you know it's not just a story. On number 11, the answer to number 11 is E. The reason why the answer is E is because what they're doing here is they're starting with the battery, then they take that battery outside and they test just the Sears brand. I'm sorry, the Sears brand is just, Sears is inside. And then they test a whole separate set outside, whole different condition with, what is that, Napa? Napa Auto Parts. So if you go from taking two completely separate cases, two different conditions, two different stores, these are going to confound each other. You don't know if the battery is not starting because it's outside or because it's Napa. I will tell you the inside one should start better no matter what brand it's from. So you've got to be careful. The temperature is confounded by the brand. You don't know which one has a greater effect. Should have tested more temperatures? Well, if you were testing each brand at the different temperatures, that'd be different. Should test other brands of batteries only if you test them under the same conditions. This would have made for a very good matched pairs design. Taking the Sears battery, testing one inside and one outside. The Napa battery, one inside, one outside. Matched pairs would have helped you eliminate this confounding. On number 12, the answer to number 12 is C. Because what you're starting with here is you are starting with your pets. And then from your pets, you're going to break them up into two different categories. You're going to have dogs and you're going to have cats. Because you're not going to compare effectiveness of one treatment between the two. Those are extremely different groups. The idea of blocking is done to minimize variation within a group. So you're going to have dogs and cats, and you're going to try with and without collars for both. Okay, so dogs and cats, each of them once without, once with. So this would be your blocking. And please, if you were to state this, you have to write blocking between here, random assignment between here, and then you're only comparing this outcome and you're only comparing your outcomes by that. But this is a randomized block, blocked by species. All right, let's just run through number 13. A is 8, because 8 is voluntary response, asking people to call the representatives. Anytime you ask somebody to do something, they're not required, that's a voluntary response. Part B is number 2, because that's convenience. They're only going to survey whoever their neighbors, their friends, and their coworkers are. They're going to go for the easiest way possible. Part C is 5. Randomly pick, each voter is assigned a number, selecting 400 of them using a random number table. That is your simple random sample. E is 6. Randomly picking 50 voters from each election district. That is stratifying. You are picking from each strata. Call the 500th person. Well, that's systematic. Randomly pick several city blocks and then pick 10 residents from within each block. That is going to be your multi-stage. The reason why this one's multi-stage is because you're picking blocks. That's the first thing. So that could be considered a cluster. And then within each cluster, you are picking a simple random sample or a convenient sample. 2 steps, multi-stage. Whereas H is randomly select several city blocks and interviewing everybody on that block. You are getting everybody within that cluster, so that is 1, but you might not be hitting all of your different clusters. All right, for number 14, our experimental units. Change my font, this is going to be way too huge. Experimental units are going to be our candy packages. Because what we're looking at is we're trying to figure out what affects the sales of the candy, and we're looking specifically at the candy's packaging. How many factors are there? Whenever I ask you how many factors are there, please take the step to not just say the number, but actually list what they are. The factors in this case are the color and the type of packaging that it's in. Box, bag, roll. Now, what we can do is we can multiply. We have 3 options here. There are 3 options for the second one. That means that there are a total of 9 treatments. And the response variable, what we're trying to measure here, is the sales of the candy. Or if you wanted to talk about the effectiveness of it, of the packaging. Oops, a little bit too big. Ooh, hello, Spinny. Look, that's fun. Effectiveness of the packaging, the sales of candy, that's what we're measuring in this case. But again, if we have 3 options here and 3 options here, 3 times 3 is 9, because I could do a white package box, a white bag, a white roll. That's 3. A green box, a green bag, a green roll, 3 more. Silver box, silver bag, and a silver roll. Total of 9 options, 9 treatments. Now, number 15. 15, what they're asking you to do is to design an appropriate experiment. That's going to be actually making your breakdown. When you talk about this, what you have to talk about is what you start with. Block by break or fractures. If you wanted to label that injury, that's fine, and then we would break it off by blocks. Make sure you tell me how many is in each. 18 bone breaks, 30 bone fractures. You must state random assignment after that, and then list the 2 different options. Now, when things are blocked, you are only comparing within that block. So you're not going to do just one comparing healing time and then all the sentences coming together. You're blocking and comparing healing time here. And you're comparing healing time here as well. Now, as it's not listed, you might want to go through this and state that the experimental units is going to be the children who have broken bones. Your factors are going to be cast or a cast and bone builder. You might want to list that some of your confounding variables are whether or not it's with bone breaks or with bone fractures. So you might want to go through and list that, but you also have to state that you are comparing your response variable, which is healing time. All right, number 16. This is from our chapter 11, where you have to make sure that you list and describe everything that we're doing here for my random sampling. You want to start with assigning each student in the district. You could either say it from 000 to 24,900. You could have gone from 0001 to 2,500. Doesn't matter. You could have either stated to use a calculator or a random number table to select 200 numbers. Throw away any repeating numbers. If you're using a random number generator, like from a calculator, you don't need to state that you're excluding values from 2,500 or 2,501 all the way up through 9,999. If you're using a calculator, you don't need to state that. If you're stating using a number table, you do. You do have to specify, throw away any repeating numbers. And students responding to each number would be selected. And then you're only going to select the first 200 non-repeating numbers. If a stratified random sampling procedure is used, there's a lot of different things that you could go here. Because we're talking about such big groups, I would stratify by grade level. And I mean by what school it goes to, elementary, middle, or high school. You might want to break it down even further into grades like kindergarten through 12th grade. But I personally think elementary, middle, and high would probably be nice enough stratas, simply because kids at different levels have different opinions in food. You're probably not going to find many kindergartners who like sushi, but you might find a high schooler who does. And similarly, you might have little kids who still like mushy plain food, whereas high schoolers want a little bit more variation in it. So we're looking at stratifying by some form of a grade level, either actual school level or grade levels themselves. And then you also might want to explain why. One statistical advantage of using a stratified random sample is an SRS. Remember, every single sample is equally likely to be selected. And that means it's possible for you to select a sample that has nothing but 12th graders in it. It's not going to be very representative. If we stratify, that's going to ensure that you choose students from each grade level and that everybody is in fact represented. Okay? other good reasons for that, but that is the high point there. Here's another problem that we have done before, how you would use random numbers to conduct this simulation. The big thing is here, making sure that your proportions match the situation that you're given. So for this problem, for part A, I would use the digits 0 to 24, double 0 to 24, or 1 to 25. That's going to be an M because it said that you had 25% of your letters showed an M, 10% showed the and symbol, so I'm going to say 25 to 34, or 26 to 35 is the and symbol, and everything else, either 35 through 99 or 36 through 99 and double 0 would be try again. And you have to specify that you're going to use the random number table, and get the digits 2 at a time. You must specify that because the number 1 is different than the number 1, 2. And record each number, under each number, whether it's an M or an and or a try again. Stop if you have 2 M's and 1 N. You must specify when to stop, otherwise we could go on and on forever. Count how many numbers there were, which would represent how many bags the customer would have to buy, the consumer would have to buy. All right, so if I actually look at this, and I want to go through and figure out what the heck is going on. Let's see here. 69 is an X. 7 is an M. 49, nothing. Try again. 19 is an M. 76, ain't no thing. 33, there's my and symbol. So if I count out how many that is, that's 1, 2, 3, 4, 5, 6. So it's a total of 6 bags. 6 bags needed to get 2 M's and 1 and. On the second round, my 48, that's a throwaway. Try again. 32, there's an and. 47, that's a try again. 79 is a try again. 28 is another and, doesn't give me what I need. It still counts towards what I'm doing. 31 is another and. Okay, I still need my 2 M's. 24, up, there's an M. 96, I'm going to toss that out. Let's see here, 47, got to toss that out. And 10, there's an M. Actually, should have written it below. Probably a little easier to see it this way. So for this round, it took me 3, 6, 9, 10 bags. So I can put all of this information together to make a conclusion. Excuse me. So my conclusion here would be it suggests that it might take an average of 8, because that's my average from my personal sample, to get the M&M symbols, but it could take up to 10 bags. Now we want to mention that because that is significant. You might want to say as few as 6 or as many as 10, but you have to state 8 bags as the average. Number 18. Okay, whether or not this is an experiment or an observational study depends upon whether you are imposing any conditions. Well, in this case, you're actually making some people drink grape juice. You're imposing that upon them, which makes it an experiment. Not statistically significant. It says the differences in changes in blood pressure between groups was not statistically significant. That goes back towards if I were to do a completely random trial, and if I were to do it using random numbers and see what a purely random, no effect would have on this, the answers that I would get from it compared to the answers that I would get from my experiment, they're not much different. There's very little variation. The differences among blood pressures varied the same as it would by chance. So if I were to have a control group, the measurement of response that I would have there and the measurement of response I would have from the grape juice would not be much different. It might be a little lower, it might be a little higher, but it's fairly similar. And the reason why we assign subjects to groups is to equalize the effects of unknown or uncontrollable sources of variation. Remember, control what you can. Block what you can't control. I cannot control all sorts of things. And in this case, I cannot control smokers versus non-smokers. There is a huge difference in the health and blood pressure of smokers and non-smokers. Block what you can't control. It says, since everybody's blood pressure was measured at the beginning and at the end, it says, okay, explain why the researchers bothered to include the control group. It doesn't matter when you record measurements. You've got to understand that things such as the time of the year, the week, weather even has a effect on blood pressure. Moods, whether or not they're going through different levels of stress. So it's always good to have the control, even if you measure something before and after. The researchers probably studied only non-smokers so that you don't get blood pressure in smokers to be confounded with the grape juice. Confounding causes confusion. So blood pressure from smokers is probably higher. So we don't know if the change in blood pressure would be due to smoking or the grape juice. Did they have too many cigarettes that day or not enough? Now, if they were to do this using both smokers and non-smokers, I would recommend blocking. Now, this is not random. This is blocking smokers and non-smokers, and this is just my recommendation. And then within each block, do a random assignment for grape juice or not grape juice. See, for each block. And then within the blocks, compare the results, but not between the blocks. And again, you would want to repeat this process for each of them. You'd want to compare the changes for each of them. And finally, please understand you will have material from Unit 1. This is our probability stuff. If the can claims to have 12 ounces of soda, which percent of cans are underfilled? Well, you're going to do your z-score equals your data minus the average divided by the standard deviation. So we get a z-score of -2. And if we're looking at underfilled, then I would go in my calculator. I would do normal CDF from -99 to -2. Because you're trying to find the percent. When they give you a z-score and you're trying to find the percent, you use normal CDF. Now, if a can is found to have 12.3, again, you're going to do the same thing. You're going to do 12.3 minus 12.1. Divide it by the standard deviation, you get 4. That means your z-score is 4. Now, anything with a z-score of 4, that means you're 4 standard deviations above the mean. That means you're going to have a very small percentage of people that actually have that amount of soda or have more. So I would expect that to be an outlier, something that's not an expected answer. And you could go through and you could do the normal CDF from -99 to +4 and see what percentage of this, what percent you're in, or to go from 4 to +99. Now, number 20, R&D Books reports they sold an average of 640 books. All of that information together, you again go through and you do your z-score formula, value minus average divided by standard deviation, you get 1.5. The z-score of the highest number of books, being 1.5, corresponds to having 6.7% of the data above that value. That's the highest value. It would mean the data is not approximately normal. Okay? All right, guys. Sorry for the announcements interruption, but I hope this helps you out. Please keep track of any questions that you might have, and we'll go over them together in class. Bye-bye.